Hello everybody. So today I will talk about calculus. The topic today is about application of integration and derivative. So now I will show you how to answer. Let R be the region enclosed by y equals to ln x, y equals to ln of s plus 1, y equals to number 0, and s equals to t. And we know that t is greater than number 1 if Vt, that is about the volume, is the volume of the solid obtained by rotating R about the y-axis, then the limit of this one equals to what? So now I will show you how to answer. So if we look carefully, form number 1, we have two regions in here. So we have the region number 1 and we have the region number 2. So because we have Vt, that is the volume of the solid obtained by rotating R about y-axis. Y-axis, that is about this one. And R number 1 and R number 2, they rotate about y-axis in here. So in this situation, we can use about shell method. The formula of this one, that should be about volume equals to 2b, and we have the integration from a to b, and we have s f of s ds. So from the region number 1, we have v equals to v number 1 plus v number 2, because we have two regions in here. That's why we have v number 1 and v number 2. About v number 1, that should be about from 0 to number 1. So we have 2b, and we have the integration from 0 to number 1. And we have s, the function in here, that should be about ln of s plus 1. And we know that in this one, there should be about the upper function minus the lower function. So the upper, that is about ln of s plus 1 minus the lower, that is about this one. And we know this is about y equals to number 0. So we put number 0 in here. And this is the integration of v number 1. Now let's go to v number 2. There should be from number 1 to t in here. So we need to use the upper minus lower. The upper, that is about this one. The lower, that is about this one. But on the question, they don't want to calculate about Vt. They want to do first the derivative of Vt. So if we do first the derivative of this one, we have the formula in here. For example, we have f of s equals to the integration from a to b, f of t dt. So if we do first derivative of this one. So we need to do first derivative of b, and the value of b will change for t. So we have f of b minus, we do first derivative of a, and the value of a will change for t. Now we can do this integration. So if we do first derivative of number 1, you got 0. This one you got 0. Because they are the constant. So when we do first derivative of this one and this one, we have 0. Because if we put number 0 in here, number 0 in here, they got 0. Now if we do the next one, first derivative of t, we have number 1, and later that the value of t will change for s in here, here, and here. So we have 2b t, and we have ln of t plus 1 minus ln t. The next one, number 1, if we put this one going here, you got 0 in the bottom. So we don't need to calculate this one anymore. Now, the next one, we need to find the limit. So I will put this one going here. Next, we have the formula ln a minus ln b equals to ln of 8 over b. So this one we can simplify. So in this situation, I can put t in here, go to the denominator. So when t approaches to positive infinity, this one will go to number 0, because 1 divided by positive infinity, you got 0. For this one, t divided by t, we have number 1. So this one you got 0. ln number 1, we have number 0 in here, because we have 0 over 0. So we can use about L hospital. So we need to do first derivative of this one and this one. So this one, we have negative 1 over t squared over 1 plus 1 over t over negative 1 over t squared. Now, we need to simplify this one and this one on numerator and denominator. So we just have only 2b over 1 plus 1 over t. When t go to positive infinity, this one we have number 0 and we just have only 2b. And this is the final answer we need to find, and we need to select about b. This is the end. Thank you for watching.